Hello everyone, I'm Samoche Ajimai, the current founder for Circuitwise Consults, and today I'm here to introduce you to our new channel known as Circuitwise Academy. So our goal for this channel is to spread the knowledge of electronics and electronic circuits, empowering learners with the essential skills needed to navigate and innovate in the world of modern electrical systems. So at Circuitwise Academy, you will gain deep understanding of the fundamental electrical concept, which is voltage, current, resistance. We are also going to delve much into the practical circuit design and analysis. We are going to learn some few troubleshooting techniques for electronic system. We are also going to learn application in various fields, from consumer electronics to industrial automation. We are going to make this course as beginner friendly as possible. We are going to delve into the basics of most of the things that we do and see in our world, how circuits are built and so forth. So to start that, we are going to first have to explain the backbone of all circuits, or the backbone of all electrical system, which is known as electricity. Okay, we all know electricity powers our modern world, from the smallest devices to the largest infrastructure. And at its core, electricity is the movement of charged particles. Okay, we are going to speak about them. It's the fundamental form of energy, and to understand or truly talk about electricity, we need to understand three main concepts, which is voltage, current, and resistance. So in this presentation, we are going to explore these core concepts. We are going to understand the relationship between these concepts through Ohm's law. We are going to distinguish between the different types of electrical current and examine real-world applications. And by the end, you will have a solid foundation in electrical principles that govern countless technology. The name again is Samoche Ajimai, and this is the first presentation from Circuitwise Academy. So what then is electricity? Before we can fully define electricity, we need to go back to the atomic structure. So we all remember from our basic chemistry and physics that we were shown, or we were made known of something known as the Bohr model of the atom, where we had a nucleus. This nucleus contained protons and neutrons, and around the nucleus we have rings where electrons are. So electricity is derived from electrons, and these electrons, or let's say the term electricity, is simply or a result from the movement of charged particles. These charged particles are in the sense of positive and negative. But how do we come by positive charge and negative charge? To explain that, we need to understand electrons and ionization. Okay, so metals, as we've come to know, are elements that have loosely bound valence electrons. Valence electrons are the outer electrons on the atom. These metals have loosely bound valence electrons in the sense that these electrons can easily dislocate and move around. So for metals with high level of conductivity, their electrons are able to move freely. When these electrons are lost from the outer shell, the number of protons the number of protons inside the nucleus of the atom becomes greater than the number of electrons on the outer part of the electrons. Hence, the metal or the atom becomes positively charged because it is lost electrons. And there are some atoms that also have an affinity for electrons. Okay, so when a neutral atom, which is an atom which has the same number of electrons and the same number of protons, when a neutral atom gains an electron, that neutral atoms become negatively charged, and as such we have positive and negative charge, and the flow of these charges results in the movement of electricity. So if you've come across a battery before, you see that on the battery we have positive and negative. Okay, so the electrons flows from the negative side, and then it is attracted by the positive side. So when you connect a wire through, or when you connect the positive and negative sides together with the use of a wire, the electrons will be flowing from the negative side, and then they will be entering the battery again through the positive side, and this will be going on and on and on until an equilibrium is reached. And when equilibrium is reached, you see that the battery is no longer discharging. At this point, the battery is of no use as it has lost its electricity. Okay, and please don't do this. If you connect a bare wire to a battery, the wire might heat up and then you might get some slight bends. Okay, so mostly between the wire and the battery, you connect loose in between, like an LED bulb, which is going to light up when the connection is complete. Okay, so to understand it better, we are going to explain some three main concepts. We have the voltage, we have the current, and then we have the resistance. So how will we explain voltage? So voltage is like the pressure that drives the electron through the conductor. Okay, you can think of voltage as, let's say, a water pressure in the hole. So the higher the voltage, the larger or the higher the rate of flow of electrons. I don't know if what I'm saying you guys understand. Okay, the higher the pressure, the higher the flow of the electrons from the negative to the positive. So batteries with high levels of voltage are emitting high levels of electron at a specific time. Okay, so the common sources of electrons or electricity, we have the DC batteries, we have the AC outlets, and then we have the solar cells. In our next lecture, we are going to talk much about DC and AC. So for now, don't worry about that. So current is the rate of flow of electrons past a certain point in a circuit. So inside the wire, when we pick a small section of the wire and we start analyzing the quantity of electrons that are flowing at that point in the wire per unit time, that's the current. So the higher the current of an electric source, the higher or the larger the amount of current flowing through the conductor at a specific period of time. So voltage is like the pressure. Okay, it makes sure that there is a large amount of electrons coming out from the negative as opposed to the positive. So the positive will be exerting a large amount of drawing force. The negative will be, so it's like a push and pull when it comes to voltage. Okay, the positive side will be, the higher the voltage, the higher the positive side will be pulling on the electrons, and the higher the negative side will be releasing the electrons. For current is the rate of change of the electrons per unit time. So when we pick a small quantity of the conductor, how much electrons are flowing through that point per unit time. Okay, that's our definition, or that's what current is. And as I said, we have the direct current and then we have the alternating current, which we are going to discuss into more in our next lecture. Okay, and what is resistance? Resistance is the opposition to the flow of current. So every material exerts some level of resistance on the flow of electricity. Okay, these resistance as a result of the electrons reacting with the atoms inside the material. So either the electrons are going to be absorbed, they are going to be emitted as heat. Like there are a lot of ways that metals offer some certain levels of resistance to the flow of electrons. Okay, some the temperature, high temperature increases the resistance of the material, the length and area. The longer the material or the thicker the material, the larger is. Okay, thick wires actually decrease the resistance, while long wires actually increases the resistance of material. And the material properties in of itself, so copper has a very low resistance, but rubber has a high resistance. Okay, and this resistance can be also be related to the fact that some materials are conductors and insulators. When I was talking about the electrons, how electrons are generated and all this, and I forgot to speak about that. We have the conductors, we have the insulators, we have the semiconductors. We'll be speaking more into this when we are doing transistors. Okay, so resistance is a material's tendency to resist electric flow and is measured in ohms. current is also measured in ampere, and voltage is measured in volt. Okay, so it's like friction for electricity. Okay, so this friction results in the electrical energy being converted into heat, and there are different material resistive properties, which is why we used copper and rubber for insulation. Okay, so it's not all cases that this resistance is bad or in negative. So in old incandescent bulb, they actually leveraged the principle of resistance to generate light, in the sense that the filament inside the incandescent bulb will heat up when current passes through due to its high resistance, and this heat, we saw it as light in that regard. Okay, so before that, what's the relationship between all this? Why is this all important? Okay, this brings us to something known as the Ohm's law, and the Ohm's law states that the voltage is equal to the current multiplied by the resistance. This relationship allows us to calculate one value when we know the other two. So when you know the current and resistance of material, you can calculate the voltage, and then vice versa. Okay, and real world application, we have the batteries, we have the chargers, we have the light bulb, and then we have circuit design. Okay, so in circuit design, we are actually, I like to describe circuit design as an art where we control the flow of electrons using components that are either passive or active. Okay, so you use resistors, capacitors, batteries, and all these things. You connect them all together to control the flow of electrons in an art form that will result in a desired functionality. Okay, so what are the key takeaways from this lecture? We've been able to discuss the basis of electronics, where electricity is the flow of electrons and is the thing that is powering our modern world. And we learned some core concepts such as voltage, which we represented as the electrical pressure measured in volt, current, which represents the flow rate, which is measured in ampere, resistance, which creates opposition, which is measured in ohms, and then we spoke of the Ohm's law, which is the relationship between all these three key concepts and how to calculate any electrical value when we know the two. Okay, so the Ohm's law, you can state it as V is equal to IR. So coming next, or in our next section or lecture, we are going to explore analog and digital circuitry in great length, and we are going to keep on building on this foundation. Okay, so the aim of this whole lecture series is not to do an in-detailed theoretical analysis of electricity. No, we are just learning the base that we are going to need for practical work in order to build circuitry. Okay, so that's it for now, and I'm going to see you guys next week. Thank you so much.